2.3 from page 456. I just want to give you guys a couple different problems to do. Well, I'm going to start off with the very first problem. Number 1 says we want 2 to the 4x equals 8. Okay? And this is an equation I'm starting with because I already showed you guys how to solve it. I gave you one idea that we can use. What was it? Get the same base. We want to get the same base. Do you guys see how to do that? Well, you probably do because this is question 1. They made it easier. What do you do here? Yeah, we rewrite the 8, right? And so I'm going to say 2 to the 4x equals 2 to the 3rd. And so then what happens? Yeah, but when I say that 4x equals 3, I say that must be true. I never answered this question. Someone might ask, why? Yes. There's something else that I need, though, for it to be true, okay? And it is because an exponential function is 1-to-1, so it has an inverse. Here's what I mean. If I say that x squared equals 16, am I sure that x equals 4? No. Why not? Yeah, you get x equals 4 or x equals negative 4. And that's because x squared is not 1-to-1, so you kind of don't know how to undo it. You actually get multiple answers. But if I have a function that is 1-to-1, I know it has an inverse, and I know I can somehow undo it. And today I'm going to show you guys how it is we undo it. By the way, you guys did this correctly, and you got x equals 3/4. I just hadn't said why yet. And honestly, you didn't care. You just want to know how to do it. Okay? But in order to be able to do more complicated problems, we need to understand what it is we really did and know that we can do it. Okay? So, here's a kind of an instant replay, the new way. Okay? The new way, step 1, isolate the exponential function. And then 2, take a logarithm of both sides. Okay? So that's my process I'm going to teach you guys today. Isolate the exponential function, take a logarithm of both sides. All right, well, problem 1 is kind of stupid because step 1 is already done. We have an exponential function on the left-hand side, 2 to the 4x, and on the right-hand side, we have something else, 2 to the 4x equals 8. Okay? So what I'm going to do here is I'm going to say we take a logarithm of both sides, okay? And I would do this. I would say, well, the log base 2 of 2 to the 4x is equal to the log base 2 of 8. Okay? And what I'm telling you guys is that if you pick the same base for the logarithm as you have for the exponential function, because they're inverse functions, they're going to undo each other. So you know what I'm going to be left with here on the left-hand side? Just 4x, which is what I want. And now I get the log base 2 of 8. I guess a problem is I'm not sure you guys know what this is. Although I know you could figure it out, right? How do I, let me do that over here. How would I figure out what the log base 2 of 8 is? Well, I'll set it's equal to some letter like Q. Right? And then what do I write down? 2 to the Q equals 8. And all of a sudden, I'm kind of redoing it the old way, right? And I get Q equals 3. And so eventually I get this. 4x equals 3. X equals 3/4. That seems kind of lame. Let me show you one more thing you can do. When I have 4x equals the log base 2 of 8, there is a formula that we learned last time, which can help me, for example, to do it on the calculator. It's called change of base. And so if I have the log base 2 of 8, you could change the base to whatever you want. Like I could do the natural log. And what's the natural log? What base? Thank goodness, I don't have to sing again. So we could write that this is equal to the natural log of something over the natural log of something. Do you know what it is? Natural log of 8 divided by the natural log of 2? Really? Yeah, let's see. So if I take my calculator, and if I type in, well, where's natural log? It's right down just below my x squared key. I have a log button and then a natural log button. So I'll hit the natural log of 8 divided by the natural log of 2. It gave me 3. Question? Well, the way the change of base formula works, and this is what we worked on for homework for today, is you always put what's in parentheses up top and you put the old base on the bottom. Okay? By the way, another way you could do it, if you want, is you could do log base 10 of 8 over log base 10 of 2. Either way, you could check that you're going to get 3. If I type in log of 8 divided by log of 2, I get 3. Okay? So these are the change of base formulas. And if you had trouble with that on the homework for today, maybe we could do a couple of those in a few minutes. Okay? But I'm hoping that this may help too. You guys have questions so far on this? All right, let's look at number 8. Number 8 says 9 times 3x. No, that's not what it says. It says 9 times 3 to the 7x power is equal to 1/9 to the 2x power. This is quite tricky, I think. One of the things that makes this one tough is that the bases are not the same. We'd like to get the bases the same. All right? And then we might be able to deal with it a little bit. I guess one thing I'd like you to discuss is what do you think we should try to make our base? The choices I hear people say are 9 or 3. All right? I think I would lean towards 3, and let me show you why. Okay? Because if I have 9, how can I write it? Yeah, but how can I write it in terms of 3? It's 3 times 3, or it's 3 squared, right? So I think the first thing I'm going to do is I'm going to take this 9 here, and I'm going to write it as 3 squared. And here I have 3 to the 7x power. Okay? Whereas over on this side, we're going to rewrite the 1/9 as 1 over what? 3 squared to the 2x power. And now I almost have everything with a base of 3. I have 3 times 3 to the 7x power is equal to, I would really like to write this as 3 squared over 1 if you want. I want to take the reciprocal. Is there something I can do? What can I do? Right, so instead of this exponent saying 2x now, what's it going to say? Minus 2x. Because we took the reciprocal, right? So we almost have the bases the same, not quite. You know what I'm going to do now is I'm going to use some laws of exponents that I learned a long time ago. When I multiply, well, let me do the right-hand side first. When I take a power of a power, do you know what I can do with those exponents? We can multiply, right? We can say that the right-hand side is equal to 3 to what power? Negative 4x. You know, just like if I have 2 cubed squared, we know that's 2 to the 6th, right? That's kind of in my mind as I do the right-hand side. Yeah, Matt. Oh, yeah, where'd that squared go? That's bad. Thank you. That squared should still be there. Okay. No, I lost the 2. That would have been bad. Okay. But now I do want to do something to this left-hand side. Okay? So again, I want to use a rule of exponents. I'd like to just write it as 3 to some power. When I'm multiplying expressions with the same base, what do I do with the exponents? We add them. And so you know what this is going to become? 7x plus 2. Because I add the exponents. Okay? So number 8 is kind of nasty. But once you get this far, because the function is 1 to 1, so it has an inverse, what can I now say? Well, 7x plus 2 must equal what? Negative 4x. And from here on out, it's just solving. 2 is equal to a negative 11x. So I'm getting x is equal to negative 2/11 after a lot of work. Okay. I want to give you something with a little bit of a different flavor, I think. Number 17 says we have 70 plus 90 times e to the negative 0.1 t equals 75. And we're supposed to solve this equation for which variable? Yeah, t is the variable. Remember, e is a number, right? So I want to try and get the t by itself. The problem is that t is up there in the exponent. Okay? But that's okay. That's what I'm going to try and go get in a sense. All right, so let's do this. Well, we have to do step 1 of my 2 steps, right? Step 1 is to what? Yeah, so you know what it is I want to isolate? I'm going to go ahead and underline what I want to isolate. This e to the negative 0.1t, that's my exponential function. that I'd like to get by itself. I'd like to isolate. Okay? So I have to get rid of the 70 and the 90 at some point. So you know what the first step is we'll do to both sides? Yeah, let's subtract the 70 from both sides. So let's see. Now I have 90e to the negative 0.1t is equal to 5. So that's okay. And do you know what the next step is? Let's divide by 90 because, again, we're still trying to isolate the exponential function. Okay? And so I divide both sides by 90, and I get e to the negative 0.1t equals, well, whatever 5 over 90 is. Okay, 118. I'm just going to leave it like that for now. Okay. And now there are two methods that I mentioned for step 2. The old step 2 was get the same base. The base on the left-hand side is e. There's no way I'm going to be able to write this right-hand side with a base of e, at least not very nicely. Okay? So I'm going to do the new step 2, which is I'm going to take a logarithm of both sides. You have to figure out which logarithm to use. Do you know? We're going to take the natural logarithm. How come? We have base e, right? And so you have to pick the logarithm that corresponds to the base you're trying to undo. And so my next step is the natural log of e to the negative 0.1t is equal to the natural log of 5 over 90. Okay? And now on the left-hand side, what do I get? Yeah, the natural log and the e kind of undo each other. And so what am I left with? Just negative 0.1t. Does that make sense to people? The natural log undoes the exponential function. Matt?
Do you bring down the power when you take off the natural log? Why do you bring it down?
That is how it's going to happen. They undo each other, okay? It's because what a logarithm does is exactly brings down the exponent, okay? It undoes the exponential function. So this equals the natural log of 5/90. And so I guess my last step would be, what would you do to both sides to get the t by itself? I want to get t by itself, right guys? You could divide by negative 0.1. So you could take this thing and divide by negative 0.1. You could also multiply by negative 10. That's another way to do it. But either way, this is what I get, this crazy answer right here. Okay? And I'm curious to know, what do they put for an answer to this problem in your book? Because sometimes we'll leave it that way, and then sometimes we'll use a calculator. Okay? My preference is you can learn more sometimes with this. Now, when I look at the book, they say that the answer is 10 times the natural log of 18. That's weird. And they didn't quite write this. They wrote the natural log of 1/18, so they simplified like Barb did, divided by negative 0.1. Okay? So what the heck did they do to get this? Well, you might understand that dividing by 0.1, what fraction is that, 0.1? 1/10. When you divide by 1/10, that's like multiplying by 10. So you might think the answer is this, negative 10 natural log of 1/18. And that is correct also. Okay? All these things are going to give you the same numerical answer. I mean, if I type into my calculator natural log of 1/18 divided by negative 0.1, I get that. If I type in negative 10 times the natural log of 1/18, I get the same thing. And if I type in 10 times the natural log of 18, I get the same thing. It's all around 28.9. Well, I guess they're all equivalent, right? But I guess the question is why? I understand why these two are equivalent. Dividing by 1/10 or multiplying by 10, that's the same thing. Do you guys know how they got to the last answer? Let me show you. That's why I wanted to do this example. A reciprocal, right? You see this negative sign? Remember the third log law says that I'm allowed to bring that up here and write it as 10 natural log 1/18 to what power? Negative 1. And that's how it turns into 10 times the natural log of 18. Because the negative 1 power says take the reciprocal. And that's a nice trick we're going to use again, so I wanted to make sure you saw it.